Okay, let's get the content and the show on the road. So what are we doing today? So today we're starting this topic called measurement, and measurement involves things like perimeter, area, surface area, volume, these types of words. In particular, we're going to be particularly interested in the shape, the rectangle, the triangle. Oh, look at let me try that again. The triangle. And we're also going to be particularly interested in the circle. But it's not a very good circle. So what I want to know from you in the chat, or if you're willing to share it, raise your hand, is what is the formula for the perimeter of these shapes? And in fact, so who would like to, because the first thing we're going to start with today is perimeter. And maybe someone can even tell us what is perimeter, but I want to know what are the formulas, because we're going to use them throughout today's lesson. So who knows the formula for the perimeter of a rectangle? I'll give you a little hint. We often call that. We call that. And we'll call this, let's call this side S1, S2, S3, and then over here, we'll talk about something called a radius. Okay, Kuchle, can you help us with a formula for perimeter of a rectangle?
So the formula of the perimeter of a rectangle is 2L times 2B.
Okay, so 2L plus 2B. Perfect. Kuchle, that is absolutely correct, because the 1L and the other L give you the 2L, and then the 1B the second B. Okay, so that's the perimeter of a rectangle. Could you help me with the triangle?
The triangle is A plus B plus C. So side 1 plus side 2 plus side 3.
Perfect. So, basically, if all the sides are different length, you just add them together. In the perfect scenario, when they're equal, maybe you could do something different. But for our purposes, you basically just add up the sides. And while you're on a roll, what about the perimeter of a circle? In fact, I think it even has a different word to use.
Is it 2 pi r, sir?
You know your stuff, man. So it's called the circumference. And the circumference of a circle is the fancy word for the perimeter. So basically, what would I get if I went the whole way around? And it's going to be 2 pi r, or sometimes we write it as diameter times pi, because the 2r, basically 2r is the same as this.
Radius is
Okay, now this is the building blocks for the first part of the session today. So we're going to use this to help us solve problems about perimeter. Okay. So give me a thumbs up if you've got these formulas in your head and you understand how they relate to the perimeter of these shapes. Okay, so step 1 in measurement is making sure you're comfortable with perimeter. So let's do some questions. So very first question, what is the perimeter of this shape? And you can just pop your answer in the chat once you've done that. Okay, remember I said perimeter of the shape. So we're trying to figure out what is the distance around the outside of this shape called a rectangle. Okay, so I see a lot of answers coming in. If you just counted it, you would get 40, or using the formula we just went, we said 2 times 15 plus 2 times 5, which would give us 40, and it would be 40 centimeters. So remember, with perimeter, we always have a unit, and the unit is just going to be centimeters in this case. Awesome. That looks good to me. Okay. Let's go to a next question. So this is a more irregular type of shape. And I'm going to tell you that the perimeter for this shape is 30. Now, I want you to work out what is the value of this length, this side over here of this shape. So take a moment to think, what is perimeter? What does perimeter mean? It means the distance around the outside. So it would be going all the way around the outside. What is the length of X going to be? If I was doing this in an equation, we'd have it like that. Okay, 16, 21, 24 plus X is 30. And we take away 24 from both sides, and we should get 6 centimeters. It does look a bit like a boot, eh? Not to cause all. Fantastic. Okay, so you guys are definitely, pretty comfortable with perimeter. What if I said to you, find me the perimeter of this shape? Now I've left one of the sides blank, and so maybe if someone's willing to give us a hint, or someone can point us in the right direction, how are we going to find the perimeter? What do we need to do first? Kuchle, what do you find helpful?
So I think we should use Pythagoras.
Yes, Kuchle, yes, Pythagoras. So first, find what GH is using Pythagoras. Oh, love it, Fukudo. Love it, Komutsire. Find what that is. And then once you found what that is, use that to help you find the perimeter of the triangle. So I'll give you a moment, and then once you've got the answer for GH, pop it in the chat. And then using that answer, you can find me the perimeter. Aha, sure, you guys are going very fast. So yeah, so what do we have here? Square root. So we should get, for GH, we should get 12. So you're going to notice in this section, applying the theorem of Pythagoras comes up a fair amount. And so you need to get comfortable. Now, I used the shortcut way, but it also wouldn't have been wrong to say, call this X and then gone 15 squared equals X squared plus 9 squared. All I did was I just jumped straight to this stage where I would have brought this across. Okay, well, what's my final answer? So we know that this is 12. And so the perimeter of this shape is going to be, oh, Emigle, I love it, 36 centimeters. Okay, so already, oh, Faith, you've got it. Awesome. So you have already found the perimeter of rectangles. You found the perimeter of triangles. And sometimes you have to use Pythagoras to help you with that. So that's good. I like what I'm seeing. I like what I'm seeing. Now, what have we left out? We've left out one particular shape. Okay, this is a little bit more sneaky. Maybe, okay. I want you to find me the perimeter of this shape, but I want you to look very carefully. This isn't a normal circle. There's something a little bit special about this circle. And so as you start to find the perimeter for this shape, I want you to think about, how do I have to take, at the beginning of the lesson, we saw that this formula could be used for the circumference of a circle, but you have to modify it a little bit here. And I want to see, can you modify that? And if anybody is willing to give us a hint as to like how we need to modify, that would be useful to us, and you can pop your hand up. So Awami, let's go to you. Awami, what do you think we have to bear in mind as we do this one?
I think since the circle is half, we also have to halve the equation. So.
Okay, perfect. So you have to halve the equation. Is there anything else, Awami, that we might have to take into account?
Because
I think you got.
I can think.
Okay, perfect. No, absolutely. Awami, you've been super helpful. Thank you so much. Amukelani, do you want to tell us, maybe, would you add anything to what Awami has said?
Yes, sir. I think the half of the green line is 3.5 centimeters in the other half. So we just have to, I think, add it together, and it's going to give us the full length of the green line.
So basically, yeah, I love what you were going with the green line, because the green line has, and the blue, so the blue curved bit and the green bit have to be added together to get our perimeter. And so that is what we're going to do. Let's see in the chat what we've got going on. So if we look at this, the radius of this shape is 3.5. And so the diameter would be 7. If we were, dealing with this whole thing over here is going to be 7 centimeters. So when we find the perimeter of this whole shape, we're going to say 2 pi r, in fact, let me leave a space for that, divided by 2, and that is the blue bit, plus 7 for the bit at the bottom, the whole diameter. And so in here, we're going to put 3.5. And so now we're going to have to use, oh, I see, you know what, these 2's are going to cancel out. But so how do we halve it? So if you basically, to halve this, all you need to do is take the whole thing and divide it by 2. And so now that I'm looking at it, these 2's actually cancel out. And so I want to know in the chat, what's my final answer going to be? So what I've done here is I've doubled the 3.5 to get the green bits. So I got 7 for this green bit. Let me write it in green. And then I'm trying to find the blue bit. And what I've said is I take 2 pi r and I divide it by 2. But I'm still waiting for my final answer for the perimeter of this shape. So I'm going to take my calculator now, and I'm going to say pi times 3.5 plus 7. And it basically, if I round that off, I'm going to get about 18 centimeters, or 17.995, but then we would round up to 18. Okay, so already we see how we can take these perimeters, and the moment we start chopping the shapes up, it becomes a little bit more interesting. Busisiwe, let's go to you. What's your question?
Sir, can you please start over with the perimeter?
Okay, so all the perimeter is going around the outside of the shape. So do you see the red, sorry, do you see the blue and the green? Busisiwe? Okay. So all I've done, perfect. So all I've done is the green part is the 7, because I doubled the radius to get the diameter. And then blue part was just this original formula divided by 2, because it's half the size. Can you see, like, if I had the whole circle, I would have 2 pi r, but here I cut it in half. So I had to divide it by 2. All right. So take a moment to think about that, but we're going to have a chance to practice that again later in the lesson. And if you're feeling a bit rushed, guys, now's a good time to take a screenshot of this page.
Mr. S, I think there's a question from Kutle.
Okay. So what I want to do is I'm going to take a question in a moment, but for those students who are feeling comfortable, this next question, I'm trying to find the perimeter of this ice cream cone looking shape. I want you to start working on that. And while you're working on that, I'm going to take some questions. So Kuchle, what is your question?
So I just wanted to know why we added the 7. Is it part of the formula or?
No, so the reason we added the 7 is perimeter means going around the outside of a shape. And so when we cut that circle in half, we had to add basically, does that make sense? Like the
Yes, sir, I get it.
on the outside. Yeah.
Yes, sir. Thank you, sir.
Pleasure. Okay, now I am taking it up a notch, but I want you to think of all the things that we've dealt with so far and what do we need to work out first? And then after we've worked out that, what do we need to do as a second step? I'll give you some time because this is a little bit harder. And if anybody does have a question, now is, oh, what flavor? Let's say it is frozen yogurt granadilla, and then it has half a scoop of that and half a scoop of blueberry cheesecake. That would be my choice when I go to the ice cream shop. And I'm not making that up, I can tell you.
Yeah, it was very specific.
yeah, it's grounded in real world experience. One of our students went to the Hout Bay ice cream shop last week. Who's one of the students? I don't know if they're here today, but I'm a big fan of ice cream, so I won't hide that. So I would love if someone can give us a hint as to what they started with. If anybody's willing to maybe share, like where I'm looking at this and it feels like some stuff could be helpful if I could get going. Yeah, Awami, where would you think to start would be a good place?
Wait, sir, I have a question, sir.
Okay, go ahead.
So ON is the radius, right, sir?
So ON is the radius, yes, yeah.
So, sir, does that make LN the diameter, which means LO is 8 as well?
You are on the money. Yes, you're exactly correct.
Okay, so you just use Pythagoras to solve for MN and LM.
Perfect. So that's exactly right. So you are pointing us in the direction of finding that side and finding that side. And you know, I've noticed something else. It feels like we don't even have to do this twice. Why do we not need to do it twice? Oh, okay, I'm gonna offer that question to the rest of the class. So I think I only have to work out the one side, and then after I've done the one side, I almost get the other one side for free. But I don't know if anybody agrees with me. So William, let's go to William. Yeah. Hi, William.
Hi, sir.
What do you have?
No,
go ahead.
Question.
Okay.
We don't have to work out one triangle, or we don't have to work out both triangles because they are identical because of
perfect.
The semicircle.
Yeah. So because they're exactly the same, basically. Do you have a value yet for MN? Who has a value for MN in the chat? So you can pop it in the chat. So some people are saying 40, 17. So, I mean, to get MN, what I need to do is just use Pythagoras. And we should get 17. So that should be 17. That should be 17. Okay, now the question is, what is my final answer going to be? And I think my final answer is just going to be made up of these three parts. So I want to know, what is the final answer? So I think, so Kitso, I'm going to come to you. Kitso, do you have a question or a comment or the answer?
So I just wanted, I wanted to answer the previous question, but it's fine.
Oh, perfect. Okay, we'll come back to you a little bit later in the lesson. But all I'm going to do is I'm going to say 2 pi r, which was the circumference of a full circle, and then I'm going to divide it by 2. And then what was the r value? The r value was 8. And so then my perimeter should be equal to, in fact, these 2's are going to cancel out. So we've got 17 plus 17 plus pi times 8. And we should get 59.13 centimeters. Okay, well done, everyone. So I feel like we've got the basics of perimeter down. Now, it turns out that in this topic, we don't just work with perimeter, we also work with area. And so I want to take a moment to think about the formulas we might use for area. But before I do that, I just want to do a quick vote. If you're feeling good and comfortable with the speed, give us a thumbs up. If you're feeling a bit lost and like we're going too fast, give us a thumbs down. Just want to do a quick check of the mood in the room. Yeah. And then while we're doing that, if you need to take a screenshot, now is a great time because we're going to move on from perimeter. We're going to move to area now. Okay. So I want to ask everyone, okay, keep those votes coming in, guys, just so I can see about how things are going. So as we move into the second half of the lesson, we're going to talk about the same shapes as before. We're going to talk about rectangles, triangles, and circles, but I want to know what is the formula for the area. So we're no longer talking about the perimeter, we're talking about the area of these shapes. So how much space is going to fit inside them? And that's what I want to know. Okay, so Kukle, do you have a suggestion for us?
Yes, sir. I believe that the area of a rectangle is length times breadth.
So length times breadth. So if this was the L and this was the B, perfect. What about the triangle?
The area of a triangle is half base times perpendicular height.
Okay, you know your stuff. So if we've got the height, and it must be perpendicular to the base, it will be a half B times perpendicular height, or the height. In the previous module, we also learned about something called the area rule. And so you could use that as well, but most of the time in this section, you'll just use half base times height. Okay, I'm going to go to someone different for the area of a circle. Does anybody know the formula for the area of a circle? Anyone? Okay, Kamogelo, what's the formula for the area of a circle? You just unmute yourself, Kamogelo. There's a little pop-up window at the bottom there. Otherwise, I see Smosh. I can oh wait, there Kamogelo is coming online, I think. Who can hear me? There we go, Smosh. What's the formula for the area of a triangle? Sorry, a triangle, a circle. We seem to be having some technical difficulties there. Okay, so it is, surprise, surprise. Did I steal this show? Who was that? There's someone nearby. Pi r squared.
It says pi.
Perfect, perfect. Okay, so in the next part of the lesson, when we look at the area of shapes, we're going to be using these formulas. However, if I give you something like a half circle, then obviously it's no longer going to be pi r squared. It would just be pi r squared divided by 2. So we have to make the same sort of modifications like we have done previously. Okay, so second part of the lesson is going to be working on area. So let's have a look at that. So before we have our little brain break, I want you to find me the area of this shape. What is the area of this shape? Okay, not particularly hard. 2 times 4.5 equals 9. But with area, it won't just be meters, it'll be meters squared. And what that unit says is it's literally saying there are 9 1 by 1 meter squares that will fit in here. Okay, so that's not particularly hard. But it's also good to go over the basics. And students often forget that when you deal with area, you have this thing called units squared. Let's do this one. Find me the area of this triangle, just to make sure you all know how to use find the area of a triangle. So thinking about the formulas we just discussed, we definitely have a base, we definitely have a perpendicular height. So a half times the base times perpendicular height, that would be 8, that would be 7. And we should get 28 centimeters squared. Yes. Awesome. Okay, so that's fine. Let's do one more before our break. I want to know, what is the area of this shape? No, it's not the perimeter, not the circumference, the area of the shape. There we go. Okay. Yes. So the formula would be pi r squared. And since the radius is 5, we would just say it's 25 pi. Or if we were forced to use a decimal, it would depend on how many decimal places they wanted us to round to, but it could be 78.54. And it just depends on how they're asking. Okay, so the good news is we're well set up for the second part of the lesson, which working with area. But what we need to do is we need to invest in ourselves quickly. So I want everybody on their feet, and I want you to do your favorite stretch, and I want you to smile at the rest of your class and show them how much you care about yourself, and that's why you're investing in yourself by stretching. So let's do it. And I'm going to turn my light on so that there is a light. And what am I going to do? I'm just going to, double click my hips. Ew, that feels fantastic. If you feel good after your stretch, let us know in the chat. I want to see if you're enjoying this as much as I am.
Come on, guys, join in.
I can't tell you. Oh,
I see William's doing it. Kitumete.
Oh, loving it. You just that little
Nagasi,
blood flow,
thing.
looking awesome. Fantastic, my people, fantastic. So let us all have a little bit of fun. What we like to do is do a thing called a little brain break. And so I want to know, what is a fancy cookie plus a banana times a chocolate chip cookie? And this is just a little bit of silly fun that we like to do, just to let our brains relax during the lesson. So I want to know, based on what you see on the screen, what is this going to be? equal to using your you guys are going quickly. I'll give you a hint. This first one is going to be 10. And you know that because together that will be 10. Yes, Young, I see you got that. Well done. Now be careful with the bananas because each banana is going to be worth 1. So 1, 1, 1, 1, 1, 1, 1. Okay, so now, once you've done that, you need to figure out how much each of the biscuits are worth. And then you can figure out the final answer. So this would be, keep those answers coming, everyone. So that will be 3 and that will be 3. And so what is my final answer going to be? Lots of people are saying 14. Let me just check. I'm not sure yet. So BODMAS says 1 times 10 will get done first. So that's 10. 3 plus 1. And the winning answer is 14. Well done. Well done. Okay. That was awesome. Well done, everyone. You definitely got, Ruth got it. Kametse got it. Maneo got it. Awesome, everyone.
Well done, guys.
Okay, so let us go back to what we were doing and finish off the lesson with some stuff on area. I want you to work out for me the area of this semicircle. Find me the area of this semicircle using what you've learned earlier in the lesson. All right. So remember the formula, the normal formula is just this. You may have to adapt it a little bit. Now, how would we need to adapt it? It looks to me like we would just go, we want not a whole circle, we want half a circle. And so what would that look like? What would the final answer be?
Mr. S, we have an answer from Kutle.
Is Kukle's hand up? Oh, look here.
Yes.
Okay. So Kukle, what is your answer?
So I got an answer of 16,08.
Okay, let me see if I agree. Let's just see in the chat. Thank you, Kukle. A couple of people, okay, I need to check that. So I'm going to go in my calculator, pi times 6.4 squared. And then I'm going to go divided by 2. And I get 64.34 centimeters squared.
So would
Yeah.
it still be 6.4 because 6.4 is the diameter?
Oh, yo. That is a impressive catch there. Love it. You see, I was being a little bit too relaxed. And so actually, you're quite right. This should be 3.2.
Yes, sir.
Love it.
Good one,
Love it.
Kutle.
Thank you.
Okay, so the final answer is this. So we're going to go pi times 3.2 squared divided by 2, and we should get 16.08, and that should be centimeters squared. I love it when students kind of, when we have something like that, because we always know we'll remember that. We won't get caught like that again if we have an experience like that. So thank you so much for that. Okay. All right, back to the ice cream problem. Except this time, you are finding me the area of the shape. So I want to know, what is the area of my ice cream cone? Over to you guys. So think about what you know and what you need to work out. And then I'm handing it over to you. And then if any students have a question, now is a great time to raise your hand. I will try my best to answer. Otherwise, you can just get on with this question and pop your answer in the chat. So I see there's some discussions about 3.2. Aha. Okay, so let me just keep that bottom one in focus while others work on that. So the way that I got 3.2 is, can you see that in the shape, the diameter is 6.4? And one of the formulas that we need to know is that diameter is just a radius plus radius, or two radiuses. So in order to get, if I want to find the radius, I just halve the diameter. And what's half of 6.4? It's 3.2. So that's what I was doing there. Okay, what about the area of this shape? Well, I think it's going to be the area of a triangle plus the area of a semicircle. And I need to be careful that I don't get caught as to what I need to find in each one. But I think this one is going to be a half base times height. And this one is going to be pi r squared divided by 2. So that's my thinking. So I'm chopping my circle in half because there's only half a circle here. And then I need to make sure that I get half base times height. Now the base is actually going to be both of these. So a half 16 times 15. So this bit here is going to be 16 altogether. And then we get that. And then what's the radius? The radius is just going to be 8. Now I see quite a few answers coming in. Now watch out for that. The 16, I think, is going to catch some students. So watch out for that. This is 16 because there's 2 8s. Okay, so be careful here. Some of you are getting, let's see, most of you, well, let's see what happens. 64 times pi divided by 2 plus, I get 220.53. 220.53, and that is going to be centimeters squared. So have a look and see if you understand where each part goes. Basically, the bit over here is the half circle or the semicircle. The bit over here is the triangle.
Mr. S, are you able to take a question from Vuyani?
I am, yep. Hi, Vuyani. What can I do for you?
Okay, maybe he put up his hand by mistake.
Okay, no problem. All right. Are there any questions, comments about that? Otherwise, I'm going to squeeze in one more thing today. But I think you've done well. Like I really, we've got a good foundation of perimeter and area to work with going forward. And so I'm going to move on to, yes, the last question for the, well, let me sneak this question in here. And I'm going to take a question then. I want you to try and find for me the area of this shape over here. So this is going to, I think we're going to finish with this one today. What is the area of this shape over here? And then while you're working on that, I'm going to take questions. And if anybody's unsure, maybe I should just write this. This says 600 and this says 400. And then there are, this is saying that's equal to that. This is equal to this. And then go from there. Okay, did somebody have a question? Or
Yes,
where to? Or who was that? Sorry, someone else?
yes, sir.
Sorry.
I wanted to,
Oh, sorry, Mr. S. Lena Miller is asking a question. It's just that
Okay.
her hand wasn't up.
Oh, no problem.
Oh.
Go ahead.
so how did you get 220 square root centimeters instead of 120 centimeters?
I think maybe it has to do with the, can you see how this thing over here is 16? I think that's where you're going wrong. It's not 8. The base of my triangle is 16. So I go a half base times height. So there's my base, there's my height. And then for the top bit over here, I'm going pi r squared divided by 2, but my r value is 8. So I think that's where I'm losing you.
Oh, yeah, so now I understand.
Awesome. Awesome. Thank you for the question. So let's see what it feels like this is a 3-piece one.
Mr. S, are you able to take another question?
Oh, where to? What is your question?
Oh, so no, you just answered it.
Oh, perfect. Glad I could help. So let's think about what I sometimes like to do is build a little formula before I start to help me keep track of what I know must go in. And so since I know that there's going to be a half circle involved, I've got that bit. Then the next bit is a rectangle. So it's almost like my brain knows I'm adding up all the different pieces. And then I just leave a space and go and hunt for the things I need to know still. And so I'm pretty sure the radius, if that's 600 is the whole way, then half of it is going to be 300. And so this would be 300. Just to get you on your way. Yeah, relay. I'll unmute and answer your question if I can. How's it going? Can you hear me, relay? So okay, I think we had a couple of technical issues there. So what I want to point out here is that we have 400 over here. These were equal, and that was 400 over there. And so we don't need more than that, because to find the area of a triangle, all you need is the base and the perpendicular height. And so here's the base, and here is the, oh, turn my thing sideways. So here is the height. So that's why I've got a half 400 times 400. For the rectangle, I have 600 times 400. And then for this, I've got a half, yeah, so I've got pi r squared divided by 2. So let's see what we get for our final answers and pop them in the chat, guys and girls. Let's have a look. Okay, so we should be getting, if all is well, 461.67, and that should be meters squared. Now, it is possible to make a silly mistake along the way, and we're not going to have time tonight to go into every single detail. Some of you will need to trace your answers back and see maybe where you made a silly mistake. But if I could just ask you to take a screenshot now, and Lebo, if I could ask you to also get ready. I'll put the answer up here, but it looks a bit more scary when it's up like that. But we're gonna call it a day for today because we've done quite a lot already, and I think that the main goal today was, could you get comfortable with perimeter and could you get comfortable with area as it relates to these three main shapes? And then could you start to begin to do things where we chop the shapes together, like we make some sort of fruit salad with them and we start putting the pieces together? That was the main goal. Now, you may need to re-watch this video again later, and that's completely fine. But yeah, we're gonna pause to end for today.